accurately tracing the paths of the planets, which didn't move haphazardly after all. Using complex circular motions called epicycles, Ptolemy could predict their prescribed paths and changing velocities. In other words, Ptolemy's system reliably predicted the future behavior of the planets, another step in man's journey to understand and control the universe.
The Ptolemaic system was extremely complex. It had all these planets going in loops, and it worked beautifully, but it was just wrong. The idea that you can predict something doesn't mean you understand the fundamental principles behind it.
Ptolemy's system did not accurately reveal the universe, but it didn't try.
He essentially showed that the positions of the planets could be calculated for any time past or future. It was a tour de force of mathematical understanding. Interestingly, the astronomy seemed to stand still for centuries after that.
In fact, after the collapse of Rome in 476 AD, astronomy actually lost ground.
Europe fragmented into smaller powers, and a lot of the wisdom of the Greeks was lost.
1,000 years later, a new theory would confront accepted beliefs about how the heavens worked and would move mankind one step closer to a theory of the Big Bang. During the 15th century AD, an idea called heliocentrism claimed the sun, not the earth, was at the center of the universe. This horrified Christian clergy, who felt it contradicted the word of God. If God created earth and man in his own image, then earth and its devout inhabitants must be the center of everything. Ironically, the champion of a sun-centered universe was a devout church deacon from Frombork, Poland, named Nicholas Copernicus.
He was a cathedral administrator, working to help collect the rents, helping people who were sick. But in between, he was working on astronomy.
Copernicus was troubled by Ptolemy's complex heavenly mechanics. But he found an elegant solution. When he moved the Earth from the center of the solar system and replaced it with the sun at the heart of it all.
When Copernicus put the planets going around the sun, he discovered that the planet Mercury, which goes around in about 3 months, automatically fell closest to the sun. And Saturn, the slowest planet, which goes around in about 30 years, automatically fell at the outside edge. Copernicus wrote, "In no other way do we find such a sure harmonious connection between the size of the orbit and its period." That seemed almost magical.
Copernicus also insisted that the Earth was rotating, that it spun completely around on an axis every 24 hours. The heavens didn't move. We did. Stars chasing across the sky each night were merely an illusion created by the rotating Earth. Likely afraid of church reprisals, Copernicus withheld publishing his theory until he was on his deathbed in 1543. But his book, Concerning the Revolutions of the Celestial Orbs, paved the way for Johannes Kepler, born in 1571, the champion of observational science.
Kepler was the real hero here because he was the one that really came out and trumpeted to the world that the sun has to be the center.
Kepler had at his disposal a trove of astronomical data collected through years of staring at the sky.
When he chugged through his observations and did the calculations, realized that not only was the sun center of the solar system, but the perfect circles were a figment also. It was uglier philosophically, but it really matched the data.
Kepler improved on the Copernican system by hypothesizing that the planets traveled not in perfect circles, but in ellipses around the sun. Kepler's data also pointed to a strange phenomenon he struggled but failed to understand. As planets approach the sun, they speed up. Further away, they slow down. Together, the sun-centered universe and the variable speed of the planets best explain what we see here on Earth.
Suddenly, and for the first time, the sun-centered picture gives better predictions than the Earth-centered picture. And then you have not only something that's driven by data, but does what science is supposed to do, which is to make predictions which are good.
But as one cosmic riddle appeared solved, another remained. Kepler saw that the sun influenced the speed of the planets as they traveled through space. But how? Before anyone addressed this mystery, dogma and science collided in a conflict that reverberates to this very day. At the turn of the 17th century, Italian astronomer Galileo Galilei would take the theories of Copernicus and Kepler, that the sun was at the center of the solar system, and prove them right beyond any shadow of a doubt. He did this with a new technology that would change the course of history.
The telescope, in some sense, is the most blasphemous, the most seditious, the most revolutionary, and the most splendorous instrument of science.
All of science received the greatest of gifts in this tool that brought distant objects close.
Once the idea got out that you could take two lenses, line them up in such a way, put them in a tube, and make a spyglass out of it, that would spread like wildfire around the world, as it did. And so the issue now is not who's got the telescope, but do you now know what to do with it? Are you looking in people's windows, or are you looking up and out into the universe?
Galileo improved on the design in 1609 by grinding his own lenses and creating one that could magnify an unprecedented 30 times.
And with that telescope, for some reason, he decided to look at the sky as opposed to the incoming ships to the Republic of Venice. And what he saw completely changed.